All right. Hello, everyone. This is Jay for the Nuke Junkie YouTube channel. And today I'm going to present part one of a two-part video that I am putting together based around the assembly language um, way of creating programs. Um, this is not a common thing that we see today with the modern PC, especially on Windows, because Windows has a way of what it does and requires interfacing with its libraries and such, and its programming interfaces. So assembly does not play well into that. And I do have read several articles just out of general interest that you can uh, program in assembly on Linux. That is a possibility, and people do it. However, there is obviously, higher level tools such as C and such, C++ that can be used there as well. But today we're going to talk about what I would call old school assembly, old school programming, and specifically it's going to be related to the 6809 version of assembly. 6809, for those of you who may not be aware, was a processor that was very popular. I believe it came out in the late 80s, and it made its way into computers from that point on for quite some time. One of the more notable computers that it did show up in was the Radio Shack, Tandy Radio Shack color computer line. It was in the color computer 1, 2, and 3. Um, and it's a neat little processor. Other processors that were real popular at that time were the 6502, which was in a bunch of um, computers of the time, most notably the Commodore 64, um, which is actually a 6510 processor, but it was fairly identical to a 6502 as far as the way it worked and the way it was programmed. The Apple II also used 6502 in its hardware, and also many of the Atari computers at the time were also 6502 based. So, for those of you that may not be aware of how a processor uh, uses the code that it's given, essentially what a processor is just a state machine that you give it an input and it runs it through its internal logic and produces an output. Um, so by learning what input produces what output, you can get a desired effect out of the processor. So all processors have what is called registers, and they all have what is called a flag register as well. And then, of course, they have the computer hardware provides memory for the processor to interact with. So I'm not going to get real heavy into actual assembly or how you program assembly in these two videos. My intent is more to show the tools that are available that I use particularly, and just how to get those tools to give you a file that can be put into a computer that runs the 6809 and have it perform some sort of function. So I am using as my test environment as far as what output is going to be produced. I am using the MAME emulator. It is, for those of you that aren't aware of it, it is a multi-purpose emulator system that can emulate many computers from, way back in the 70s up through, I believe it goes up into early Intel processors as well. So you could see stuff like DOS and that sort of thing. So I don't believe it does any kind of Windows or anything like that, but it does have quite a breadth of what it does. It also has a second piece that is basically a arcade style emulator. So any kind of the old arcade games, like for those of you that have been around as long as I have, Space Invaders and Frogger and all the Williams like Defender and Robotron and all the way up through it does like TurboGrafx emulation and other arcade cabinets that have been out through the decades. So that's big overview of what MAME does. If you're more interested, you can go to MAME and look into it. If you really want an in-depth um, video on MAME and how it works and how to use it, I would be willing to do that if I get enough comments that people would like to see that sort of thing. So be sure to comment below if that's something you'd like to see me do. Um, so as we move into this, like I said, you can see on the screen that's presented in front of us here. This is the MAME output window of what it is actually emulating the computer to be doing. Right now, it's black because I am running it with a debug mode, and that debug is basically a way of giving you a picture of what the processor is doing at any given moment in time. So just real quick, if you look here, you can see I'm not going to get it too terribly into what all this stuff means at the present time, but it's given us a cycle count for the current instruction that the processor is going to implement. This BeamX and BeamY is based on the video hardware that is being emulated, and it basically tells you where the excuse me, where the CRT beam is at, and you can watch that as it progresses, and that gives you an indication of where the computer is in its process of redrawing the screen for graphics. Come down here a little bit further, you see we have a flags line that is basically a visual representation of what the flags register that I spoke about earlier is doing, what ones are set, what ones are not set. This is PC is a program counter, and that is essentially where in memory the computer is currently looking for and then executing the instructions. So you can see 8C1D, and 8C1D here is highlighted in yellow, so that tells you where it is and what it's looking to do. The following on information here is the status of all the registers. Just real quick, I'll go through these, but like I said, I'm not going to get real in depth on what they do or how you use them. But the S is the stack register. CC is the hex representation of what the flags register holds. DP is a direct page pointer that is fairly unique to the 6809. That basically just allows you to set a particular page as the current page in memory, and it allows some quicker execution of commands based on operating in that memory page. Then we have the A register and the B register. They are both 8-bit. That is why you see the 2 zeros versus the 4. The stack register, as I didn't say before, but the stack register is 16-bit, which is why you see the 4 zeros representation of its value. Then you have the D register, which is a 16-bit register, and it is essentially the high byte of it. These two are the same as A. They are pretty much tied together directly. So if you set A, you will set the higher byte of D. And if you set the B register, you'll set the lower byte of D, as well as if you set D register to a value, it will update alpha the A and B registers as well to reflect that. X and Y are both 16-bit registers. They are referred to as index registers. They're used for typically for things like counting and progressing through loops and that sort of thing. And then we have the U register, which is actually another stack. It is 16-bit, and the 6809 had 2 stacks. The U stack is called the user stack. It's there specifically for programs to use in stack usage, whereas the S stack can also be used by programs, but will also be used by the processor when it needs to you save values and or jump to different routines and such, it will save values as required on the stack and then pull them back off when required as well. So that's a quick rundown of what we have here in the screen. And as you can see, if you're not well versed in assembly or particularly how computers work, that might be a little confusing. But um, probably in a future video beyond these two that I'm putting out currently, I may get into, or I will probably get into a more focused discussion on the processor and what those different registers do and how to use them and such. So, as I said, over here is this is basically representation of the computer's memory. The color computer that is being emulated here is a 128 kilobyte color computer 3. However, color computer, and for that matter, any 8-bit processor typically will have a 16-bit memory space, and that is from 0000 to FFFF. And that is why you'll see these registers with the 4 zeros. That way you can address the entire memory, as well as the program counter obviously needs to be able to address all of the memory as well. So just if you look over here, this portion here where it says LDA pound $0A, that is the instruction that was decoded within the debugger to basically be the representation of what the original assembly command was that it's now executing. Now that won't show labels or any sort of other features that you may use in an assembler, because it doesn't know. Once it's assembled, the only thing that the computer has to work with is these values over here, which are actual byte values in memory. So the 81CD, if you were to look at that actually in memory, will show 860 alpha, which is the binary representation of this command. So that's basically what we're looking at here. Down here I have a command prompt window, which is basically what I'm going to use and get into to show you what how you go about creating a program, and it kind of ties everything together, and we'll see that a little bit better as I get into the second part. If we move over here to this screen, you'll see some other programs. These are fairly common programs. Right here we have this is the Notepad++ program that I use as my text editor in Windows. It's a really nice program if you're looking for a good text editor other than Notepad or WordPad in Windows. This is probably one of the better choices you can go to. I currently have open in it a program called asem.bat, which is a Windows batch file, and I'm going to go through that in the follow-on video as well to describe what it does, why I set it up the way I did, and how it helps us with the assembly process. And then down here is really just a Windows directory of the tools that I have, along with the files that I use to assemble and then run in the emulator. So basically that's the overall look of what I use. I'm going to give a real high-level view of how this all works, and then I'm going to come back in the second part of the video and actually show demonstration, describe a lot of this stuff in some more depth. So basically here what happens is this file here is the asem.batch file, which is up in the left-hand portion of the screen that I described earlier. And then as you come down through here, this is an assembly file called colors2, which can be assembled. Colors2.bin is the actual binary file that gets outputted by the assembler that you would put onto a disk and then load into the Cocoa to run. Image tool is actually a file that I pulled out of the MAME distribution, and it is used to create and manipulate disk images. So that's a handy tool for that. Another assembler file, letters, which is what we're going to be looking at and demonstrating in the second part. It's binary. And then these four files on the bottom are the four application executables that um, basically are used by the assembler software, which is actually called LW Tools. You can search that on the internet and find that as well, um, and that will, get you to the description of this program. There's a linker which is used when you're going to, if you have multiple assembly files to link together, it will pull that all together and make one binary out of it for you. But we're not going to get that deep into that portion of it in these two videos. May come back with a follow-on video at some point that would describe more in depth how that works. So at the very top of this file, you see there is a file called 180k-rs.dsk. That is a disk file that I created with the image tool, and it is in a format that the color computer RS-DOS environment uses or can read, and that is where we will put the information to be read by the color computer in the emulator. So that is a big flick overview. What I did want to do real quick is let me get into another screen here. And what I like to do is I'm going to bring up a web browser, and I want to show everyone how, I shouldn't say how, where all these tools can be found so that you can go out and look at them, pull them down if you like, and play with them a little bit more. Let me bring this guy into the display so you guys can see it. This is for those of you that are only using Windows Explorer, or I'm sorry, Internet Explorer, or the new Microsoft Edge. This is Mozilla, which is Firefox. Mozilla is a group that makes software, free software, open source software, and excuse me, and puts it down into available for pretty much anybody to use. So this is Firefox. It's just a general, it works very much like you'd expect a browser to work. I just like it the most, and so it's the one that I use. So what we're going to do is we're going to go to MAME first, and I'm going to show you guys where you can go for that. So the first thing that pops up when you search Google for MAME gives you mamedev.org, and this is where you'll come to. You can read all kinds of goodness about updates. Sorry about that. And it will, you can read what was fixed, what was changed between versions. Currently, they're at MAME 0187. Here's the downloads, depending on what environment you're running in. And MAME does work in all the major platforms, as you can see. I'm not going to get into the download in this video, like I said, but that is where you would go for MAME. The next major thing we want to get tool-wise is we want to do a search for LW Tools. And as you can see, the first thing that will pop up is LW Tools, which is the project page that we want. If we open that up, this is basically a project from a guy who basically has made an assembly environment that is geared towards the color computer, but it also does make raw binaries, which could be used in general on any 6809 processor. So if we come in here, it does give you information from building from source, which would be most usable on Linux and Mac OS. It can also be used with a MingGW or CYG Win environment on Windows to build. So that is an option as well if that's something that you have or would like to figure out and get it built that way. Of particular interest is the third-party contribution. If you click here, this link will bring you to a repository of different LW Tools file directories for different versions of LW tools. The most current version is 4.14, and you can see 4.14 Win32. So that would be the one you'd want to pull down for using with Windows. It does work on 64-bit Windows. I'm running it Windows 10. It works fine. Also, if you want to, this is the LW Tools 414 download. This will give you all the source files and such uh, for being able to assemble, or I'm sorry, being able to compile the program yourself. That's what you want to do. Um, Down the bottom here, there is another note that a gentleman named Aaron Wolf has provided Win64 binaries. If you click on that, it's going to give you a download screen that you can pull down a zipped up LW tools to use. However, it is not a current compilation of LW tools. I believe it's only the 4.0 tool package, which you see here. And so there are features that have come along since then, and the 13 revision since then that it does not support. So just be aware of that if you're going to try using the Win64 binary. It does work in Windows 10. I've downloaded it just to verify that it works, but as I said, it is not up to date. So that's LW Tools and MAME. And if you want to get the Notepad program that I showed previously, that is real simple. You just type in Notepad++, and the first thing that will pop up is Notepad++ Home, and that will bring you to this screen. And this is as well a Windows-only program. So if you're not on Windows, you would have to use some other Notepad program. And if you're on one Linux or OS X, you probably have a favorite that you're using already. But should you be on Windows and still trying to use WordPad or Notepad, this, in my opinion, is a much better alternative. It actually will do highlighting for different programming languages, including assembly, although it is somewhat limited depending on the processor that you're trying to set up for assembly commands for certain processors. So, but it is very usable as a Word file. I'm sorry, as a text file editor, and also does a pretty good job if you're using it for programming purposes as well. So that's the environment as far as what you can go get stuff to use to do this. So that is really all I want to show in the first part of this video, kind of what your appetite for what is out there and what we can use to do assembly on the color computer. And I am going to, like I said, I'm going to come back with a second part to this video, which will basically dive into these tools a little bit more and give us a really good idea of how all this stuff works together, so that if you want to start getting yourself into assembly, maybe just try to figure out what it is, and if it's something that you'd really like to put and start developing, you could do that. So I would appreciate if you would like and subscribe to the Nuke Junkie channel. And also, I just want to mention I am going to put up some links after the video. One of them is going to be to the OG Stevie Stroh YouTube channel as well. Steve is a guy who has been really putting out a lot of good information specific to the Coco, in general videos on all kinds of different topics. He's run a basic programming language series of videos, which is pretty interesting if you're interested in how BASIC worked on the color computer. He also runs a weekly web talk session that's called Coco Talk, and that is basically where a bunch of Coco community users, or I should say community users for the Coco, get together and just talk about current stuff that's out there, new things that are coming out, hardware, software, all those sorts of things. Also jumps back into does a lot of game reviews of you know, games that were on the Coco back in the day when it was a you know, the new platform out. And as well, last week, number 16 of the Coco Talk was put out, and he was kind enough to invite. I would encourage you to check that out. And also, obviously, his other stuff he has that interests you. So that's all I have for this video. Thank you for your time. And like I said, please subscribe and like and check out the other channels.